Hi, my name is Lex Sable, and I'm doing my tutorial for high-speed aerodynamics in spring of 21. This is project 1. That's my ID. Alrighty, so I already have open Fluent and my coordinates from MathCAD. All I did for MathCAD was use the given graph to edit the two angles that we needed to edit. Change the throat radius to the correct throat radius, and keep the 80% bell nozzle the same because it's already set to 80%. And then I could not get my path to work to actually export the file, so I just clicked select all on the points that posted themselves when you just put /desktop for the path and put them in Excel so I could format them correctly. So that's all I did there. And now in geometry, you use space claim. And you have to make sure that the file or the workbench file is already saved when you start, or else the space claim surface will not transfer properly into the mesh or design modeler. So for this one, first things first, you change the options to meters because these are in millimeters. Then, next I click these two. So, if it'll let me click X, maybe. I usually click like this, just so when I upload my file, it puts it on the right plane. Cool. And then to mirror the top to the other side, click on plane, and it was already pre-selected on the Y. So we don't have to do anything there, or anything else there. No, you just make sure that you go into sketch and use the sketch mirror because the other mirror does not work correctly. So click on plane, plane, object, object. Cool. As you can see, it made a second curve. You just can't see it until you put in 3D sketch. And then you just connect the lines. And that is it for making the bell nozzle in space claim. For the conical nozzle, all I did was come over here to where I'm about to dimension now and find the lowest point, which was the correct throat radius that we had, and then just delete all the rest of the line to the other side by using the trim tool. It's right there. Yeah, I just made a line from the y-axis, so it always lined up with the correct throat radius. And then the other thing we're going to do is a 2D sketch of this, so we need to make another plane so we can sketch it out. Click on plane, click the z-axis. Boom, now we have our plane. Hit escape so nothing weird happens. Go to details, dimension, click on the plane, and then click on the objects. And then pull out all the dimensions. As you can see, correct exit area, correct throat area is right there. And that is the smallest point I can confirm. Oop, come on, let me get on X. Oh, no, I'm not going to do it. Yep, if you look closely, that is the smallest point that we have, so that's the throat. Cool. And then this dimension. And this one. Not missing any. Oop, okay, cool. So now we have it all dimensioned. Take your screenshot, and then you want to make it a surface. So, make it a surface, all you gotta do is click on fill, box select, click fill again. Cool, and now you can see you have a surface, so you just gotta save it. Save it at the same place you saved the workbench file, which for me is my desktop. Alrighty, and then just click save again. Alright, cool. So now, we go into design modeler. and click generate. Fantastic. I do not know why it does this. Could not tell you. Sometimes it works, sometimes it doesn't. Great. Maybe we can do this. Desktop. Maybe it'll work now. The reason I'm not just going straight to mesh is because every time I've used Space Claim and not loaded it into the design modeler, it's never loaded into the mesh correctly. Or at all. There we go. Wish I would have figured that out when I was actually doing the project. That would have been nice. Okay, cool. And now that it's here, that's pretty much it. And just exit out. Because the meshing software definitely likes Design Modeler better than Space Claim. So now I just got to open up our mesh. And in the mesh, I actually found if you go to too fine of a mesh, it'll just not give you the correct results. You'll get a bunch of shockwaves, and yeah, they just look gross. But I also had my mesh super fine, like 450,000 units, so it's a bit overkill. So for this, you just click here for the geometry, apply, generate it up. I always like to use triangles. Oop. And then I just hit generate in between everything I do, just to make sure it doesn't break. And then you click on mesh, go to statistics, make sure you can see how many cells you have, or how many elements you have. And then element size, I believe it was 0.006 was the right one. Should be about 40-something thousand elements. Yep, 44. That's what I did before. Cool. Click on the edge, make it a name selection, inlet obviously. Then for the tops, same thing. You just gotta... Oh, hello? That was weird. Alright, but we got both our top and bottom. I call this one wall. And just to make sure that came out right. Yep. And then, last but not least, the outlet. Sweet. So, we got all our boundaries set. That is it for the meshing. Click update mesh. Still recording. Fantastic. Alright, now we're on to setup. Without precision. Sorry, my mic was muted. I was just calculating my inlet numbers again. I misplaced them. And now on to the outlet. And I have these numbers already. This was my outlet pressure that I calculated. And this was the outlet temperature I calculated. And then for reference values, I did from outlet, because these values were the furthest off when they are auto-generated, because inlet's pretty close. So this one, change the temperature to 745.339. And the desired velocity, or the velocity calculated for the exit was 2,447. And that was getting 548 for the speed of sound and times 4.46 for the Mach number that we expected the exit, or that I expected the exit. Don't think I need to change anything else. Oh, density is actually another thing. Calculated density at the exit is 0.16377. Okay. And then for initialization, I use standard from the inlet. Perfect. This is a bit off. 3, 5, 6, 5. Alrighty, and I will unmute when the calculation converges. Or unpause. Alright, it's been a few minutes and it converged after 780 iterations. And these are our results. There's Mach number, velocity. I don't even know if that changes. And here is just pressure. Density, temperature, and I believe it was properties. Yep, speed of sound. Cool. And I just took screenshots of all of those from here, and then for the plots, for the XY plots, you need to make a center line. So for that, go to results, create, line/rake. This was negative 0.13. This is 0.2. Great. Close. And then you go to vectors, edit, line 4, display. As you can see, it goes over a little bit, but it doesn't give you results that end in 0. You don't have to have it exactly the length of your funnel. It just drops it off. So then from there, you just go back down to XY plot, and same thing, everything you need. Click on your center line, save and plot. Boom, there it is. And then to get it to write to file, just click write to file, right. And as you can see, this is where I saved all my stuff. But I'm not gonna do that now. Just these are the same: density, velocity, Mach number, temperature, and speed of sound. Alright, and that is pretty much it for the tutorial. The only other third thing that I didn't have to do on this one was the conical nozzle. And that one I already explained. I just chopped off the end, made it a straight line at 15 degrees. And yeah, for the MathCAD, I explained that. 2D pictures. And then for my calculations, I just use the isentropic table we were given. So, that concludes the tutorial. Thank you for watching. Appreciate it.